Our first speaker for this session is Dr. Stephan Thiel. Stephan is an applied geophysicist in the Mineral Resources Business Unit at CSIRO. Stephan has a vast experience in the investigation and application of electromagnetic geophysical methods applied to solid earth, mineral systems and geothermal systems. Today, Stephan will present on some of the insights from the Gawler Phase 2 project. Thanks, Stephan.
Okay, well, hello everyone. So today I want to talk about a pretty big project, the Gawler Phase 2 project, that really started a few years back when I was still at the survey, and it's been a very complex one. I just want to start first off acknowledging the land that we're meeting on, the traditional owners also of the land on which this research has been conducted. So that's the Amiak, the Gawler Ranges and Far West Coast peoples. And we pay our respects to the past, present and future elders. So just a bit of a background to this program. You probably remember from a few years back that we held a big a challenge, the Gawler Phase challenge, where we had a lot of machine learning AI kind of applied to some of the pre-competitive data. And I guess we learned a lot about, or something about the prospectivity of the state and where we might lack actual information and also pre-competitive data coverage. So that's why we went basically in and did a follow-up of collecting more data in an area that was largely unexplored in the central western Gawler Craton, and that's really the reason why the Gawler Phase project began in around 2020. So I think it's fair to say that this has been one of the most complex projects we've ever had within the survey. There's certainly been a lot of people involved, complex in a sense just because of the remoteness of the area, land access, and just trying a lot of different techniques at the same time. So you can see here a whole range of people. It's pretty much almost the entire survey have been involved. And because there's even a second page, just to kind of tell you that there's been quite a lot of contractors as well. So it's a really complex, long-lasting 3 years that we've been on. There's a lot of data that we acquired. The idea was really to, throw the entire GSSA kitchen sink at the problem to really open up this area in terms of the geophysics, geochronology, geochemistry, and petrophysical data to just give our best chance to understand what's going on in terms of nickel, copper prospectivity, but also the gold prospectivity that's existing there. I think on every table I've actually seen that you can scan the QR codes that will take you straight where the data actually sits. There's also some videos online that you can watch about the individual techniques that were used, so there's a wealth of information for you to have a look at. So I want to really run through this talk by giving you some of the highlights. We had a fantastic workshop yesterday. If you haven't been there, I think there's a material online available that you can look at. So what I'm trying to do is in the next 10 minutes is to give us somewhat of a summary of that, which will be nearly impossible. But there are certain highlights that are really worth highlighting. So in terms of regional geology, this area is a late Archean belt in the center of the Gawler Craton, and we're looking at the Morgathin complex, which is just the northern extent of these Archean rocks. It hosts the Challenger gold mine. There are some sniffs of nickel copper, as I mentioned earlier. Gulf bore gold is also there. And it's really been defined by metamorphosed in the formation during the Sleaford orogeny around 2400, 2500. So some of the new data that has come out, and this is really work that Claire Waite and Dylan Brown have done, is to take quite a lot of samples of the drill holes that were available, mafic and felsic, samples for whole rock geochemistry, but also dating, shrimp dating, uranium lab dating, and really just focusing on some of these prospects that are out there and trying to understand the geological history of it. What we did find, which was quite interesting, is just a sort of progression, and that there were multiple generations of extensive mafic magmatism that happened. And it really seemed to be extending outwards. It's almost like a crust to growth that went out from the central Archean core of the Gawler out westwards, or today's westwards anyway. So that was quite an interesting finding. And when we looked at the data, also in combination with other data sets, we realized that the Kurobi shear zone seems to be a fairly major fundamental structure that sort of separates the almost Archean, really old core of the Gawler Craton to anything that happens further out west. And it's a zone that has been repeatedly, I suppose, reactivated over time, especially around 2480, but also at later stages We're getting Kimben ages around 1700. And these are all sort of extensional events around the Kurobi shear zone that really controls a lot of what magmatism happened at the time. We do have gold, and I guess this is work that Alex van Leuven did. It's really very interesting. We obviously knew before that, it's Challenger gold deposit and Gulfbore, and the common thinking is that, this gold mineralization occurred prior to the metamorphism during the, Sleafordian originally. But some new work that Alex has done, which was quite interesting, is that especially Gulfbore seems to have some monazite growth during a time that is sort of Kimben related. So you can see in the graph up there, there's a lot of Sleafordian ages, but there are some other peaks that are happening at a later time, and that might be related to some of the compressional extensional events around 1700. Again, possibly control what happened along the Kurobi shear zone and having some effect a bit further out, at least around Gulfbore. So that was really interesting. I want to talk in the next few slides a little bit about the geophysical data acquisition that we have done. So we concentrated now before on the geochemistry and the geochronology, which gives us some idea about the trends in geodynamics and the fertility of the system. With the MT survey that we did, this just shows the extent of the new data that we've collected. So all the black points on that map are the new MT sites. The yellow ones are the ones that we had before GP2 existed. So it kind of really shows you that we try to cover the area and infill into the Ostlem MT survey, which is 50 kilometers spaced, to get much better resolution. So it's just some of the results that we get out. We have 2D, 3D inversions, and I think Peter highlighted earlier that these are available now for CSIRO. So this gives us a fairly good view of what the lithospheric architecture looks like, at least in the crust into the upper mantle, underneath the Gawler Phase 2 area. And you can see areas that are really quite resistive here, which are sitting under the gravity high, which I'm going to talk about in a second. So this is the area where we see a lot of the nickel-copper potential. So gives you an indication that there probably has been really high degree melting that happened and extremely depleted the crust in that area. The Kurobi shear zone sits about there, so there's also relatively visible in the MT. It can also be used for paleochannel mapping, which will be a recurrent theme with the other data sets that we have collected. So this is a depth slice at just 300 meters depth. So that's quite shallow, but even with the grid that we acquired, we quite well or be able to constrain those paleochannels, which are all these kind of red outlines here. We obviously have other data sets that equally well describe them, and this is the image of the new gravity. So the outline of the gravity survey is here in black. So this is sort of 1 and 2 kilometer space gravity data, ground gravity data that's been acquired. It's a fantastic data set, just the granularity in it is really incredible. So for example, this gravity high here roughly coincides with the MT resistor that I talked about earlier, but really quite spectacularly, all these zones are the paleochannels that I talked about earlier as well. On top of that, and sort of almost moving a bit even shallower at depth, is the NEO AEM data. So we are piggybacking on what Geoscience Australia is doing across the nation. And I mean, we thought we had a pretty big area, but our area is actually only this back here. So it gives you a sense of perspective, but we did acquire 5 kilometer spaced airborne EM data. So that's actually a fantastic data set, and GA has sort of a suite of products that are coming out where you can look at each of the individual profiles and the models, and it's quite clear that this data set is very powerful for also delineating paleochannels as well. And we also had Bao Hong Ho from the Geological Survey of South Australia looking at even other data sets. So this is nighttime thermal satellite data to understand those paleochannels more. So we really have 4 different data sets that independently match the paleochannels. So if you're interested in where they are, I think we have really good constraint of them by now. And that's obviously really important also in terms of economic geology, when you talk about preservation of these systems and how you might dissolve metals and going into paleochannels. We have a much better understanding of that now than we ever did before. In order to, I guess, link the geology with the geophysics, a lot of the drill holes that were looked at and also were sampled for geochron and geochem also had a lot of petrophysical measurements taken along those. So we used the mobile petrophysical lab. It's basically a container that you can ship out here to the core library that's been built by CSIRO. And you can take a whole range of measurements from electrical property, acoustic velocity, so really the whole suite. So that should allow you to translate what you see down the borehole out into the geology and even into the geophysics if you have the right resolution. So that's a really powerful data set as well. Carmen Krapf and some other collaborators like Nacho from CSIRO also looked at lineament mapping. Well, that's really powerful in its own right because it looks at lineaments that are occurring in the basement but also in the surface geology. And I guess the strength of that is to link these different scales together, and that's really important again for preservation and understanding which of these major features are important. And it might also give you an indication in terms of geochemical sampling that you do, or soil sampling at the surface, because you have some knowledge of where those structures are coming through. So that is a really nice data set that links to different scales as well. I want to finish off a little bit of, we were starting to obviously look at the data sets together, and we spent hours in meetings to try and make sense of it, just because of the breadth and the wealth of the data that is there. But some of the things that sort of came out, and this is really a lot of the work that Mark Pauly has done, is using his structural information, and you've seen his talk earlier on the SADM, is to bring this together and understand, where the nickel potential is potentially elevated, and his thinking is that you really have to look at some of the corridors. And again, you see highlighted there the Kurobe shear zone, which we identified as a fundamental structure, and then you have this sort of cluster growth going out from there. And you see in these sort of almost semi-parallel zones where you have higher nickel occurrences. So we think that there are sort of discrete corridors in some sense, which we believe is of higher nickel prospectivity. So to finish up, I guess the way we're trying to look at this is that these data sets will feed into what are critical elements for a mineral system. So what we hope that this work allows to do is they can look at these different data sets and they work into what really is a footprint, or I guess a definition of what a mineral system is. So you need to have it be in a fertile system. It needs to have the right lithospheric architecture to actually have ores. You need favorable geodynamics, so I think that's the work that Dylan has done. And then preservation is the key. So obviously we're seeing a lot of granulite facies metamorphism, which indicates that a lot of the rocks that are now at the surface have been sort of deeper down. But there's a question of what might still have survived, because you just do have sniffs of nickel in the area. And again, this is where the party channel mapping comes in. If you transport this material away, you have a better understanding of where that might end up. So I've just put some of the slides next to it to kind of give you an idea, or a bit of an idea of how this might fit into the whole mineral system. If you have any questions, there's an email, but thank you for that, and thanks for listening.